This video will cover metrics.opensuse.org, the implementation details, as well as what all the information actually means. Links to the tools and the code involved in the process to produce the final data that you see will be provided in the video description. But general overview is that basically there's a Python script which calls the OBS, or the build service API, to request histories, processes that data, ends up generating a whole bunch of individual records that are then sorted and summed, etc. And that data is then inserted into InfluxDB, at which point it's then graphed by Grafana. Both tools are open source and you can take a look at them if you're interested. But the net intake is somewhere around 800 megabytes of XML data that is converted into 2 million rows in InfluxDB for factory anyway, and several 100,000 for Leap. The caveats of this data: currently only requests in a final state are included, which means that they are either superseded, declined, or accepted. So this does not affect closed projects like Leap 42.3, in which basically all the requests should be in a final state at this point. But for factory, you'll notice that the graphs tend to tail off at the end, as basically none of the actively open requests at the time the data was processed are included. This is something that should be resolvable, but basically I was avoiding basically having to requery lots of data from OBS. So until a couple issues are resolved on the OBS API end, basically mostly sorting, so I can only have to re-request basically the tail end, i.e. requests that actually change. I'm basically just avoiding loading all that, gig basically of data from OBS on a regular basis. Other than that, some of the, for example, the whitelisting, as I'll talk about later, is basically something that's contained in one of the config files, which is version controlled. Currently, the ingest process does not look at the changes to that file over time. Basically, I just look at the final state. The current values basically didn't change over the ingest period, so it's not really relevant, but those are things that would make sense to do down the road. The one thing that would be nice, really nice to do, and you will see it affected in the graphs, is basically this pseudo state, the ignored pseudo state that I added, which is basically requests that are open, but we're not going to handle them in the staging process for the time being because there's some issue or we're waiting for a response on a maintainer or something like that. The issue is that basically those will show up in the backlog graph, even though really they weren't considered to be in the backlog by the staging masters as they were marked as ignored. So some of the graphs will have spikes, like something wasn't staged for a week because basically it was sitting in that ignored state. So basically removing those, processing those out would be something to add, and I have some code towards that, but those are things that aren't done at the moment. Without further ado, let's dive right in and take a look at Leap as a kind of study case just to get ourselves familiar with these graphs and what the data looks like. So first off, if you navigate to metrics.opensuse.org, you'll be greeted with this home dashboard. Describes where the code that's used to ingest the data that's presented in these graphs is available, as well as some of the pending issues with the process, and I'll update this as things change. So to start with, these are the main three dashboards that we have right now, one of which is kind of just for playing around, but the OSRT stands for openSUSE Release Tools, so just repeat for training using. Hopefully the OBS team and possibly even download statistics and some other things may eventually end up in this instance as well. So to start off with, I'm going to take a look at the staging metrics for Leap 42.3 cycle, as I think a nice beginning and end to a cycle makes it kind of easy to notice some trends and kind of understand where we're going. So I clicked on the staging dashboard, and then up here we can change what project we're looking at. So I'll go ahead and take a look at the 42.3 project. I'm going to change the time period that we're looking at, and then we can go ahead and just zoom in by left click and drag. So just looking over here at the totals, so this is basically just where all the requests that were targeting the project, what state they were in at the given time here on the graph. So you can kind of see how many are in backlog versus just open request total versus staged. So you can kind of see the kind of the volume and the speed at which the development cycle was taking place. So you can kind of see for here there was a lot of requests open, which either means As we can see, a bunch were staged. There are probably issues with them that needed to be resolved. But you can kind of tell from this, get an idea of kind of the overview of things. So here's the, this is just kind of like you see on a stock market ticker, the volume of incoming requests that were opened every day. So you can kind of see when there were big bumps. So right here we see a big bump in the number of created, and we see a corresponding bump here that were staged. So it's just some kind of overview information. This is the number of times. So some of these graph titles I'll probably go through and update over time, add some more descriptions of things. This is kind of the first draft of things. So this is the staged count. So this covers how many times requests were staged before they were actually ended up being accepted. So you can kind of get an idea for how many, when things either mistakes were made or regrouping was necessary, or there were problems that run into something. So you can kind of see that the majority of them are 1, but do get bumps to 2 and 3. So nothing so bad. Some of these graphs are more interesting to note because leap was they're more interesting to note that there was a lack of a change. So for the leap cycle was where I was developing some new staging tools that automate a lot of this work. So the fact that there is no change here from the beginning to the end is basically an indication that the automation didn't actually make mistakes. Because if we saw a large increase in the number of restages, basically, then the automated staging would have been making mistakes. So we can see the total time that it takes for a request to make it in. So you can kind of see here, these are just some normal like statistics, min, max, mean, those kinds of things. So some of them are really quick and others are rather slow. Not all this information is too interesting. Some of this is more experimentation for the time being. So you can see there's 2 graphs with the same title. The difference is the time which the data point is entered at, either when the event happens, so for example when it was first staged, or when it was closed or opened. You get a different kind of look to the data. So some of those things I'm just experimenting with over time, but again, not too interesting. These graphs are kind of somewhat hard to read because they have these big spikes, so at some point it might be interesting to filter out the large ones and just kind of get this zoomed in version of this line down here, because you can see the majority of them are really quick, time to first stage especially. I'm gonna kind of go through quick because we're gonna look at this for factory and some other projects, and I'll probably add details at different times as I'm going through it. So this is the letter staging. So if you're not familiar with the staging process, basically the kind of like more important or primary packages, things like the desktop itself, the kernel, things like that basically end up in the rings, which end up in the letter stagings, and kind of the long tail of all the rest of the packages end up in kind of like ADI stagings, which are basically like on the fly staging. So anyway, so this is just kind of an overview. You can kind of see how the stagings were actually being used. So you can see some of the stagings, like for example here, there was actually a whole bunch, 103 in B, and not very many others. So things like that were probably big KDE updates, things like that. So it's kind of interesting. You can kind of walk back in time and remember what was going on. This is just a percentage view of that. So again, trying to get a picture of what happened over time, just to see if there's anything of note to pull from these graphs. So then this is one of the interesting bits that I was targeting, trying to pull out. So this is actually who was doing the staging, so what user. So you can see JBerry Factory is myself, and Ludwig being the project owner. So you can kind of see who's doing the majority of the work here. So right in here, when this orange kind of takes over from the beginning, I was doing a bunch of the staging, and somewhere in here was when I was enabling the automation as I was starting to develop it. So you can kind of tell that it kind of was taking over here. And then the purple is the staging bot. So that's when I formally flipped it over. It was running on a shared box and running as the staging bot user. So you can see that the staging bot user completely took over from me and anyone else that was messing with it. And near the end, you can tell that Ludwig was doing some of the final work. So again, some of these graphs are more interesting to see in Factory, but you can kind of see the full cycle here. So again, you can tell that the automated tools were doing a lot of work. So if we go back and look at how many times the requests were staged, again, somewhere in here, you see there's no appreciable change. Plenty of little 2 spikes, but nothing overly interesting. Again, multiple staging isn't necessarily always a problem. It's kind of a fact of the way the process works. Just again, a different representation of who was doing all the staging over the entire process. So at the very end, the staging actually did 37%. If you assume that a majority of the work that I was doing halfway through, so of that 32%, so somewhere in the neighborhood over 50% of the work was done automatically, which is pretty cool, especially considering we didn't start with the bottom beginning. So this is kind of what I mentioned earlier, the ADI versus letter stagings. So it's just kind of a breakdown of how many were in each of those different types. Again, some of these graphs aren't terribly interesting. It's just more see what kind of data we can pull out and whether or not there's something interesting to look at. This is the request priorities, which are primarily used to increase the priority that the legal team sees, so we can get stagings finished up when they're waiting on legal review. And we'll see later, we can tell how many requests were actually in that state of waiting for legal review. So another thing to note is that basically the ADI workflow was pretty much always automatic before, which meant that the only change once the staging bot started doing everything automatically was that it runs regularly once an hour. So this basically is the same sort of graph we saw before, but broken down by ADI, and on first only simply means the first staging. So this is again just to try to see how much of the initial work is really being done by the bot, because I'm assuming at this point that the automated tools basically aren't making any more mistakes than a human would. So we're just curious who's doing all that first work, and we're assuming that all the follow-up work ends up being done by a human anyway. So again, you can see that the vast majority of it was done by the bot. There are some spikes here where I assume other people were basically doing a lot of sort of accepts, like this is again Ludwig when he was finishing up the cycle, and you can see that he was must have been running the tools more frequently than the bot, things like that. Again, some of these graphs are probably more interesting on factory, but here's one interesting one where we can tell there was a big change. So somewhere in here, remember I said, if we look back up here, this orange was me running the automated tools that I was writing on my laptop somewhere in here. I could look up the exact dates, but I don't remember at the top of my head. Anyway, so we can see the effect that that had. So basically, the time to first staging of the ADI ones, again, that was the automatic flow. So this is purely limited by whether or not someone's actually running the script. And so once that was automatically turned on, you can see that our graph drastically changes here, and the time to first staging is consistently under basically an hour. There are these spikes here, which I think I can filter out. As basically I introduced a new pseudo state where we ignore requests that we know we need to wait on for a while. So I think that's what the majority of these spikes are from looking at the data. But I need to actually go through and filter them out. So I think they're basically just expected because there are requests that end up sitting in the backlog in that ignored state for a while. And then at some point in the future, a few days later, or a week later, or however long, when they finally get staged, they basically show up as a big delay there. So you can see this is the time to first staging. Whitelisted basically just means the stagings that the bot's allowed to act on. So again, this is relevant to factory, where basically there are certain stagings that are still reserved for only humans to work on. So again, I'm just breaking down this data so we can kind of tell. I'm trying to see the impact that the bot has, because basically the stagings that are still managed by humans should essentially see no impact, whereas the ones that the bot ended up taking over, we should see a drop. So we'll see that in factory some more. Yeah, and again here at the bottom is by staging by the whitelisted first only. So we can see that basically the staging bot was doing pretty much all the work, and my user was before. So now if we switch over and let's look at the review dashboard for Leap. So I know it's a lot of information and just trying to get an overview so basically people can explore this data themselves and maybe suggest new things that we may want to take a look at. So this is just the priority graph repeated again because priorities are kind of relevant to the legal reviews, which you can see here. So here you can tell how long the different views took to complete. So some of these reviews you can tell took a really long time, but some of this data again needs to be filtered out if there were things in like the ignored state and stuff, but technically that doesn't block these reviews from being completed. But anyway, you can see that the average on most of these reviews is acceptable. It's relatively low. So for example, like the Leap reviewers, you know, we're generally generally staying in a couple days to hours. Some of them are really long. So like these ones at the end of the cycle, 7 months. So that was literally a request that basically was opened, you know, in the beginning of the process or very early on, and there was no decision made for 7 months. And then near the end, when basically everything was done, some sort of decision was made. It was either accepted or declined, and that was closed. So that's kind of what some of these big peaks are. So you can see that some basically sit for long periods of time, but the majority of them are relatively quick. Similarly with legal reviews, again, there's some really big spikes. So some things I'd like to try to figure out is whether or not there's a better way to display some of this data, because you can see these spikes basically scale the graph such that it's a little bit hard to see the majority of the data. So if we keep going here, the repo checker was something that we were working on. I was basically rewriting it, or I was, for Leap as one of our use cases. But we only managed to, I think I ran it on one request actually, because it was one that was really important to, it had issues that the repo checker basically could tell. But otherwise it wasn't used during the last Leap cycle. And again, we'll see more of that in factory. But anyway, so this is possibly more interesting than those previous representations of the graphs. So this is again similar data. So this is those same review groups that we were seeing above, but this is how many requests have open reviews for those groups. So you can kind of tell that in the beginning of the process, when there probably wasn't a lot of requests, that there wasn't too many in any of these groups. The majority of them are for like Leap reviewers and such. Again, we had a big bunch here that someone had to go through. And then later on in the process, you can tell when we're having a lot of requests incoming, the Leaper bot basically is one that will wait to see. So if you have a parallel request coming in for something that's being submitted to factory at the same time, the Leap review will basically remain open until it's approved for factory. So that's kind of what these blocks are here. Versus again, the Leap reviewers having a decent amount open for a period of time and then closed out near the end of the process. This is broken down by percentages, so you can kind of tell what is the big showstoppers that are holding up the requests. Again, the two groups are basically Leaper, which is basically waiting on the entire factory process, which includes human review and staging everything else, and then the Leap reviewers, which is basically the kind of like a risk analysis for Leap updates, deciding whether or not the updates, if they're not just minor increments, are basically worth the trouble. So those are pretty much the two review groups we expect to be the majority of the reviews, and here they are. So again, not too exciting for Leap, but just because there's less basically reviews going on. But this is those reviews then broken down by these are the develop project reviews. So basically things that requests that basically were submitted to Leap and then required a develop project to approve them. So this is just broken down by the project and the packages. So interestingly enough, one of my own packages actually had the majority or the most individual package reviews required. So basically anytime a maintainer submits them themselves, there's no review required because they are the maintainer. And if someone else, such as one of the bots, automatically submits them once they've been updated to factory, then we'd basically end up with one of these reviews asking the maintainer, do you actually want this? So again, those Leap reviews we were talking about, you can kind of see who actually did the reviews. So pretty much the majority of them were done by myself or Ludwig, and then Max is there as well. And we were pretty much the two that were working on those reviews anyway. So that's basically what you should expect for this cycle. This is kind of just breaking it down by who completed them per day. So you can kind of see it was back and forth, and the majority of the ones at the end were done by Ludwig, which again makes sense because he's making those project decisions on some of those requests that had long-standing discussions or issues surrounding them. So basically they were all closed out near the end. Some of the data that shows up as blank, these are issues I've had that I've filed with the OBS team because the data that we get from the API is, well, there are some legitimate bugs with it, and then there are some certain structures that it returns that make things ambiguous. So that is, whenever you see that, that's basically what the problem is. So similarly, the openSUSE review team reviews. So there are a lot less of these for Leap because most of the things have already been passed through either the SLE process or the factory process or both. So there's only certain cases where these reviews are added, so you'll see these numbers are relatively low, but again, you can tell who is doing the majority of the reviews. And again, broken down by day when they were basically completed. So that's what those are. This release schedule, you can check that. So that will basically annotate these graphs with the release schedule for the project that you're on. So for example, we can see when we integrated the SLE stuff. So if we go back, I think this is less interesting on this page, but if we go back to staging, and then we turn on, I gotta switch to this, and we turn that on, you can see that that actually corresponds to some of the requests we got. So this integrate SLE sources kind of corresponds to this big bulge. So I actually think that that actually happened. It was scheduled to happen then. I think it happened a couple days later, and that's what this big bulge was, because I remember doing that. And so you can kind of see that there were some big accepts after some of these spikes here, and then the final release, poof, and all of them drop off. So those make sense. So now if we switch over to factory, so this is basically Tumbleweed over the last year, factory development, what goes into Tumbleweed. So you can see some of the volumes are fairly large here. The majority, the backlog remains somewhere around 100, it seems normally. And again, this is not filtering out things that are in the ignore list. So the ignore list itself is usually seems like somewhere just under 20, maybe 15 to 10, somewhere in there. So some number of this that's sitting in the backlog is actually ignored. So those are some things that need to get followed up. But you can see some interesting kind of trends and spikes in this. It would be interesting to annotate this graph with major software releases, kind of like the Kitty stacks or GNOME updates, seems like that end up having a whole bunch of requests and kind of correlating them on the graph. That would be interesting to follow up on. For example, I know that this is actually a big Haskell package submission. So you can see it's actually a big spike up there to like 2,700, and then accepted very quickly afterwards because they were basically all in one big staging. Again, you can see that on the volumes. Interestingly enough, the stage count is actually spikes a lot higher than we saw on Leap. Again, the majority very much seems to be in the 1 or 2 category, which is pretty good, and you see no real appreciable change. If anything, you see a slightly lower amount down here. And again, we're going to try to correlate that with when the automated staging tools that I was showing you on Leap were enabled for factory. The total time for requests, you can kind of see again, we had some spikes here in the beginning. Later, if we expand this graph, which we'll look at later, you can see when there were some big jumps, when a lot of Haskell packages and other things were waiting on the legal team review. But again, these graphs aren't too interesting. Like I said, I ended up having to present this information differently to try and really see what we want. This graph, I think, is much more pretty and interesting to look at. This is, again, the staging breakdown by letter. And interestingly enough, you'll notice somewhere right there that all of a sudden we start having KL and M stagings. So you can tell basically when those stagings were actually added into the process. And then the other ones listed, and when N was added back here. So that's kind of interesting. And again, you see the kind of corresponding spikes, and usually there's a lot of little stagings and a couple big ones. Those couple big ones being KDE or GNOME and similar stacks like that, versus the smaller ones being the kernel or something like that. So if we go to these by user graph, you'll see what we expect. Basically, Dimstar and Maxlin are the two primary people doing all the staging work. You'll see me jump in there a couple times, and some others, but generally those are the two main ones. And then somewhere in here, you'll notice that the staging bot does its first work here. This was me, I think. I documented basically one case of just running it and showing everyone what it would do in production. It was enabled in here. We had a debate over how often it would run and a couple other issues with locking, so it was disabled for a couple days. And then boom, it pretty much takes over as you see the graph. So this is all staging work. So this includes ADIs, second stagings, all that kind of stuff. So some of that isn't necessarily fair from the perspective of looking for that tool, basically, when I'm trying to see what impact that automated bits have, which again, why I split this out later. So here if we look at all the staging work that was only the first staging, you'll notice that basically it's very similar to this graph, except that the green is more exaggerated, which is basically what we expect, since the bot's not doing a lot of the follow-up work. So if we just look at only follow-ups done, you'll actually note that it is doing some of the green. So basically some of the things that the bot would do would be to replace a superseded request or unstaged things that are declined, stuff like that. So that should be reflected in here, but the majority of the follow-up work is going to be moving things around to regroup them or deal with all sorts of fun stuff that happens. So if we keep going here, so here this is again just a breakdown by ADI versus letter. So you'll see there's pretty big spikes. So for example, that Haskell submission down here, you'll see there were 2K sitting in ADI. So again, that's what that was, with the pretty consistent amount in the letter stagings, but it's fairly split. Here's that big, so this is something I guess I didn't mention last time, but this is the ADIs that are in the ready to accept. So part of the process is that basically once ADI requests complete the process, they are just basically marked as I'm ready and then unstaged, and they wait until a letter staging is accepted. So once a letter staging like A with the kernel in it is accepted, all the ADI requests that are in this ready state are then accepted as well. So this is another graph that gets horribly scaled based on one time, and this is again this is the Haskell submissions, or I believe, or never mind, this is the, yeah, how long they sit in the ready state. Yeah, so I don't remember what this 1 year was. I'll have to look at that, but that's definitely skewing the graph. You'll see that factory uses the, so basically it wasn't, the priorities were never used. I don't believe they show up in the data much earlier than this, if at all, because that's something that was basically added to the process. But this is again for the legal reviews primarily, so you can tell that they are used on and off as necessary. But so again, here's the by user broken down by ADI and first only. So you see that pretty much all of the ADI work is done by the bot, which is great. Interestingly enough, this graph gives us a nice reference point. So we see the staging bot was enabled right in here. If we look at the time to first staging for the whitelisted letter stagings, which again, this means the ones that the bot's allowed to act on, you'll notice a very distinct drop here. So you'll notice you have lots of spikes and peaks here, even getting up into weeks and hours before a request is first staged, and then afterwards it's quite consistently much lower. And again, there's going to be some spikes in here with those ignored requests, but the majority of them, as you can see, are under an hour, and we'll look at that other graph below. Yeah, so again, very noticeable change on the ADI requests, basically consistently dropping under an hour. So we can see that the automation had the effect that we wanted. Again here, the time to first staging for the non-whitelisted, basically no real change because that's still being done by humans. So that's basically what we would expect. But again, these ADI graphs have the desired impact. And another similar graph where you can tell that a lot of the work was taken over by the staging bot. So this is really great because this is a lot of just kind of repetitive work that had to be done manually that is now completely done automatically. Short of that follow-up work, as we see here, is still done manually. But anyway, these graphs really show that the automation is taking over and having the desired effect. So if we move on to the reviews then for factory, so again, repeating the priority, the review team, some of these there's some really nice, interesting spikes that are interesting to go look at, get very long spikes. The Leap reviewers obviously don't apply to factory, neither does Leaper, so those are generally empty. And if we look at the factory repo checker, so basically there was that migration to the new repo checker, which we'll see in the graphs below, but I basically merged them in this graph, as you can see here. But basically there's no major change here. There is a consistently slightly higher peaks you'll see here because basically the new repo checker waits for things to be staged first and reviews them in their staging instead of reviewing them in the develop projects. So this is noticeably a longer wait consistently, which we can see in this graph below as well. So basically if we see what kind of the pools of reviews that the requests were waiting for, we can see here there's some big spikes for the legal team. At one point there was a really long, I think like an 8-month legal queue. I can't remember, I think this is near the end of it. Once I expand this to the encompass a couple of years, it'll be very obvious when big legal queue spikes were. But again, if we look at the percentage graph, you can see that that was one of the big blockers here. for quite a while. You'll also notice that the way the legal reviews were done changed as we jumped around from legal team and legal auto, if we expand this out further. But the most interesting bit is you can tell exactly when the new repo checker was enabled right here. Because basically we had no reviews that were waiting for the repo checker, and then all of a sudden, boom, we had this spike, because that's obviously the new user that was used as well. Yeah, then you can see that basically it kind of takes over. There's a lot more waiting on it. It's getting better. We've made some improvements, or made some improvements that basically allow the cycle time to be quicker, and we're fixing some of the problems that have been pre-existing. And we've improved some abilities for the staging masters to basically whitelist certain problems that actually are false positives, that are basically due to the way the rings are set up. Anyway, but you can kind of see the wait time behind the new repo checker. But again, right here, these overalls aren't too bad. But it's interesting to see this stuff reflected in the data. So again, this is broken down into, so basically things are submitted by their maintainers, which I think is the most common case. Basically when people accept things into develop projects, they forward them onto factory. These develop project reviews are then not required, but anything that's submitted automatically by one of the bots or someone else would require those reviews. So one of the biggest ones of those is the Python reviews, just some interesting stuff. And again, you can paginate through all this data and see more bits that might be interesting. The openSUSE review team reviews, you can tell who's doing the majority of those. So you can see basically it's just a couple of users that are doing the majority of them, but a lot more people involved in that, as one would expect, than say the lead reviewers. So if we expand some of this stuff out to encompass a longer time period. So here again, like I was saying, you can tell that the priorities had not been used prior to that point because it was all added into the process. So again, that's very clear from looking at the data here. So here we can tell, yeah, all of a sudden you can tell this is when it was. There was a big spike of Haskell submissions and some other things that basically were clogging up the legal review process for a while. So you can tell, you can tell that the legal queue was kind of always a delay here for a while. This huge spike that we had there for a long period of time. And then it's basically been completely converted over to the legal auto bot in that process. But this was, yeah, this graph shows it really nicely. A whole bunch of requests basically waiting for lawyer review, which was an issue for a while, but much less so now. Because again, this is a percentage graph, so it doesn't necessarily make it as clear as this graph does that it's not really an issue as much now. And if we look at the overall who's been doing all the openSUSE review team, I don't know myself, but I'm going to assume that that's obviously the first time this review group was used. I don't know if there was a previous group before that or just change in process, but you can see Dominic is doing, Dimstar is doing the majority of the reviews there over time. 26,000, man, that is a bunch. But this graph gets pretty interesting looking as well. So you can kind of see those larger trends. And if we switch back to the staging reviews for factory, and again expand the time period out to more like 5 years, again we can just select, I only went back so far with the data. So basically I think it was like any request greater than ID like 200,000 or something like that is where I stopped. But we could go back further. But anyway, one thing you immediately notice here is the change in volume. I don't know what happened right here, but it seems to be consistently higher. And one reason why it tails off here at the end, I should mention, is that basically only requests in a final state are included in these graphs. So anything that's basically open or pending that hasn't been accepted or declined isn't included in these graphs, which is why they kind of tail off at the end and hit 0. But that's something that's basically waiting on, well, I need to make some changes to OBS itself so I can query the data more efficiently, and then I can include those requests as well. So again, you can kind of tell over time, definitely been more, some spikes here in the maximum amount of times requests are restaged, but not huge amounts of change. This interesting line that develops here, I believe, was basically entirely a result of the legal queue when I was reviewing the data. So you can see some of these spikes here, 38 weeks. Like those are some pretty serious wait times. Seeing a lot less of that now, but you can kind of see that develop. And like I said, it's totally different the way it looks when you sort the data differently. The way these basically peaks develop, where they show. But yeah, busy. Lots of work for quite a while. Another interesting thing I think that shows up here in the graph somewhere. Oh yeah, so here you can tell Kulu basically doing a lot of the work and before, and Max as well. And it all transitions to Dimstar in here. And then again, you can very clearly see the staging bot taking over at the end. So some of these really large trends. Same sort of things on here. Where was the... and you can see when the ADI projects were first introduced, which is kind of interesting because there's obviously absolutely no data on all those graphs before that. This one because it's letter, but... So again, some interesting things you can tell. And while we're here, we can take a look at, say, the 13.2 cycle. These are kind of interesting to see because I assume this stuff basically is just requests that kind of got left open for a while and not cleaned up, but the actual development window basically is much more condensed and done in big batches than it is now, which my understanding is that basically that's because pretty much all the work was done in factory and then just copied over basically to 13.2. So the development window as OBS sees it is much shorter. Take a look at 42.2. So if we compare that with 42.3, there's no way to overlay this data right now. But again, you can see those big spikes, interesting data. Again, you'll see the development window is similar. 42.3 is a little bit longer. Those are much more similar than, say, that 13.2, which is much smaller. Yeah, and then this one again, similar size. The initial window being shorter, though, you can tell that's only a couple months compared to those other ones. So some other things that can be done with this. So here's an example. I switch over this comparison dashboard. So this is basically comparing two projects in the same graph, so you can kind of see. So this is the request time to first staging. So again, this looks drastically different. It's basically completely flat for 42.3, and there's a bunch of big spikes waiting weeks and days for requests to even be staged in 42.2. So again, this is basically the effect of automation without automation. So this is what we had hoped to see. Some big differences here. But this obviously kind of demonstrates some more. There's a lot of different ways basically this data can be presented, and possibly with input from others to decide what actually makes sense. So you can kind of see things like this a lot easier. Let's see. So lastly, I'll just take a quick look at this graph. So if you're not familiar, if you kind of want to look at this data a little bit more, if you're not familiar, this is Grafana that this is all being presented with. But basically, you can actually single out individual basically metrics to look at and change colors, that kind of stuff. If you hold Control and click, or Shift rather, you can select multiple ones or turn them on and off, stuff like that. And obviously the zoom we already looked at and everything else, so you can kind of go through and look at what you're interested in. For those interested in understanding more how this works or potentially getting involved in helping out, the code, as there's a link on that home dashboard page, I guess I can just navigate to that so you can see what I'm talking about. So this is the link to the repo, and this is particularly the file, this metrics.py. So this is the code that's actually used to pull all the data out of the OBS API, process it, and then insert it into InfluxDB, where it's then pulled out of there with Grafana. So basically, if you're interested in pulling out new things, this is just requesting the full request history from OBS. So you basically get an XML element basically to process over. So you can see I'm doing a bunch of like, standard XML manipulation if you're all familiar with that, looking over everything and then doing some math like subtracting the difference between dates, things like that. So if you can think of new things that you like to pull out, like to get involved, that's where all that code is. You can run this script on your own box pretty easily. And I'm around in IRC and talk about it, stuff like that. I hope you found this interesting or useful in some way. If you'd like to get a hold of us, please email us at openSUSE release team mailing list, or hit us up in the openSUSE-factory IRC channel. Have a nice day.